flow rate of 10 liters per second. So the symbol that I use for the flow rate is the Q, capital Q. Do we remember, I'll let you write the problem and then. Oh, that's okay. We'll go to the level. Now, I know probably you use the formula, but in my opinion, let's look at the Moody diagram, okay? That would be better. I mean, it's very rare for me to actually use the formulas. It's easier to go through the Moody diagram and look at it. Now, couple of observations here. Oh, it is still right. Remember, the assignment is due now on Tuesday, okay, last day of our classes. Couple of observations here. Why they say about stainless steel? Why we care about the material?
Our reference.
Huh?
Our reference.
The roughness, very nice. So we care because we need to know the roughness. And also, if you remember, out of the three categories of problems, the easy, the medium, and the difficult, this problem is in which category? Remember yesterday three categories? We are given the flow rate and we're given the diameter. Those are the key, the easy ones. Okay? So that's the easy one. So, number one thing that I will do is I will calculate the Reynolds number to make sure to know what kind of flow I have here. The formula for the Reynolds number is V D. Oh, I'll put capital D to be consistent with the textbook, times mu divided by the density. No, I'm sorry. I used to use the other formulas. Rho VD over mu. That's my mistake. Rho VD divided by mu. And V is the velocity in the pipe. How are we going to find the velocity in the pipe? Since we know the flow rate, remember the flow rate Q equals what?
V times A.
V times A, very nice. This formula I would like you to write it or highlight it so you can use it during the exam. I mean, normally I should have it, but just in case I don't give it to you or if I forget it, make sure you have it written. Q equals V times A. That's the flow rate, the flow distance, or flow rate, okay? Flow distance or flow rate. So from here, I can back calculate for my velocity V, which is Q over A, and because the area is pi over 4 d squared, it's a circular pipe, bring 4 at the top, it's 4q over pi d squared. So this is another formula that it would be nice to have it in your notes, so you don't have to do any manipulation of your formulas, have it directly. The fact that the velocity is always 4q over pi d squared for a circular pipe. Okay, that's for a circular pipe. That's how you calculate the velocity, knowing the flow rate and the diameter of your pipe. So let us plug in the numbers. The other thing that you should not forget is uniformity in terms of the units, right? So here the Q is in liters per second, and because the velocity is normally in meters per second, we need to convert the liters per second to cubic meters. How many cubic meters per second are here in the 10 liters? What do I need to do to find the flow rate in cubic meters per second?
10,000.
Multiply or divide?
Well, divide by 10 thirds.
Or divide by
divide it, right?
Yeah, divide by 1,000.
The way that I always remember it is, now I know you guys like feet, but whoa, if you have a, eh? No. No, but if I tell you 1 meter, do you know how much is 1 meter?
About 3.2 feet.
Yeah, that's what I'm saying. So This tile is what? It's 12 by 12, you think?
Yep.
So 12 by 12, so it's 1 foot, 2 feet, 3 feet. So 1 meter should be from some, well, it's a little bit bigger, but
A little bit bigger than that.
yeah, it'd be a little bit bigger than 3 tiles. Because it's 3.2, something like that. So anyway, so 1 meter is those 3 tiles. So imagine you have a cube of 1 meter by 1 meter by 1 meter. This is 1 cubic meter. So within that cubic meter, you have if you fill this with water or whatever liquid, the volume of this will be 1,000 liters. 1 liter is it's a third of a gallon, I think. 1 gallon or 4 liters, I don't remember. 1 gallon. So it makes sense that in a cube of 1 by 1 by 1, you have 1,000 liters. So to convert the liters to cubic meters, you need to multiply or divide by 1,000. Which will make it 0.001.
Meter cube.
Okay, cubic meters per second. So where are we here? 4 times 0.001 cubic meter per second. Okay. No, wait. Zero point zero zero one. No, 0.2. I mean 0.01. Okay, so it's 1, 2, 3, yes. 0.01 divided over pi times the diameter of the pipe. The diameter, you see, I already converted it from centimeters to meters, so 0.06 meters squared. Squared also the 0.06. If you do the calculations, you see cubic meters, the square meter, the 3 with the 2 cancels. So you only have meters per second as expected, and the speed of the water is about 3.53. Oh, okay, 54. Yeah, I'm going with the solution that's a little bit more accurate, but it's okay. 3.54 meters per second. So now you calculate the Reynolds number. So let's calculate it here. The Reynolds number is the density of the water, which is 999.1 kilograms per cubic meter, times the speed, which is 3.54 meters per second, okay, times the diameter of the pipe, which is 0.06 meters, divided by the dynamic viscosity, which is 1.138 times 10 to the negative 3 kilograms per meter second. And if you do the calculations, everything, all the units will cancel, and your Reynolds number is going to be 1.863 times 10 to the power of 5. It's about 186,000. Okay? So let's write those numbers here. So we know, because I will need some space, Reynolds number equals 1.863 times 10 to the power of 5. Now, remember, first of all, what kind of flow is this one? Laminar, transitional, or turbulent flow? Eh? Laminar, what's the limit between laminar and turbulent?
Less than 10
2